What is up, guys? Welcome back to another GeekaWhat video. In this one, I'm going to be building the ultimate all-white gaming PC build with some seriously powerful components perfect for 4K gaming and an aesthetic that looks top tier. This is a build you don't want to miss. In this video, I'll be walking you through part choices, performance, and showing you guys how to assemble this step by step, seeing what challenges, trials, and tribulations we face along the way. Let's do this. My new Amazon storefront is now live for my US and UK viewers. You can use the first link in the description below to compare pricing and availability for the parts in this build and all of the other recent systems featured on the channel. What's more, you can also find my favourite monthly tech picks and check out the gear we use to make these videos possible. Check it out at the first links below. I'm going to start this build off in the only way really that makes any sense, explaining to you guys what parts I picked and why, before building the system and looking at performance later. Now, at the heart of the build, housing all the components, is Corsair's iCUE 5000T. As far as white PC cases goes, this is one of the best for a few reasons. Airflow's great, build quality is fantastic, you get their high-end LL RGB fans, they're the ones with the dual RGB rings, no crappy fan business over here, plus with individually addressable RGB LEDs in the top, sides and bottom on both the glass side and the rear side. This chassis is serious, like an amazing bit of kit. Not cheap, mind, but you do get what you pay for. As far as the motherboard goes, I needed something that was Z790 so we could use Intel's 13th gen, but also white themed by nature, where the ASUS ROG STRIX Z790A Gaming comes in. This is the DDR4 version. There are also DDR5 boards available, so the choice is totally yours. And you can learn about which is best for you at the article in the description and the cards section now. This board works really well for the system today though, with plenty of connectivity, PCI Gen 5 and an integrated I/O shield with plenty of next-gen USBs and high-speed networking. In terms of the CPU, the Intel 13th gen chip I'm opting to use, I've picked up the i7-13700K. Now there are a couple of options when it comes to processors. If you're purely going for a gaming build, the i5 can save you some money, and if you want an editing-oriented system, the i9 is the best bet. The i7 though is a great middle ground, and with our 4080 graphics card, you do want to be careful you don't bottleneck it with an underpowered CPU. Other components worth noting at this point include Samsung's 990 Pro. This is basically as good as it gets when you come to looking at Gen 4 NVMe SSDs, while 32GB of Corsair's Vengeance RGB Pro in all white complete the motherboard assembly nicely. 32GB of RAM is ideal, and you may want to opt to get this in a 216GB DIMM configuration rather than 4.8. That will give you better upgradability options over time. All of these components are going to pair up very nicely with the GPU of choice. This is the MSI Suprim X RTX 4080. To my knowledge, this is probably the closest all-white GPU option on the market right now, built upon Nvidia's Ada Lovelace GPU architecture, and with 16GB of GDDR6 memory, this is one good-looking graphics card. Let me show you, actually, in fact, how good MSI's Suprim design really looks. Big reveal. Oh, yes. Yeah, I mean, it's just a really, really nice bit of kit, and with a lighter colour scheme and aesthetic, gonna work well in this case. Otherwise, we're nearly there. There is one more component to talk about, and that is the Corsair RM1200X Shift power supply. Now, this power supply is a potentially very good option for a few reasons. With the power connectors on the side, Corsair really are looking to change the game and reinvent the rules, really, when it comes to a power supply. I've never seen anything like this before, and I have to say, I commend their efforts. From what I understand, it's not compatible with every case due to power supply clearance issues, but it should work with most. So on this side, we've got a normal RM1200X, the text, all the normal design, but then if you go on this side, that's pretty cool. You've got all the different power connectors, so everything from the motherboard to the CPU, PCIe, and your SATAs, they're all very small too, meaning I'm supposing that this bag of cables are going to have some pretty diddly ends on. Oh my goodness, look at that. So these are the Type 5 connectors that we've already seen with the PCI Gen 5 cables being rolled out to the others, so a much smaller, more compact design that's going to make these easier to fit in cases. Of course, with this being on the side, the cables have to come straight up, meaning a bit more more, I suppose, resistance is needed in the design of the sleeve-in to make sure it holds up. My first time using the 1200X shift, and I'm quite excited, but the verdict on this for me is still out. We'll leave that to later when I actually go ahead and put this thing in the build. The useful element though, of course, is it's easy to plug stuff in, and it's also way easier to add in more cables later if you've got to add more to the power supply. It means you haven't got to take the whole unit out to get these connected. I think I'm losing the plot today. I said that was the final component. I'm just blatantly missing loads. A couple more bits to cover off include some fans. I've picked up some Corsair QL edition fans. They've got the RGB rings on the front and the back. Awesome for radiators. I've also got this, an LCD upgrade kit for the cooler, a part that I actually missed earlier, their H150i CAPELLX. We've used a lot of Corsair H150i's in white. I'm not really sure why. We just seem to get through them, but this is the latest iteration, the newest fans, newest water block design with an XT-based refresh. It is available with a screen. This, of course, is also compatible with any of Corsair's sort of CAPELLX range of coolers from the last couple of years as an upgrade kit. A really great pro-consumer move to see. Corsair, I'm loving it. No, wait, hang on. That's the McDonald's slogan. Finally, and actually finally this time, I promise, I've also got these Corsair's iCUE LC100s. An expensive design inspired by the Nanoleaf sort of options for the inside of the PC. Really, really cool. We'll be trying those later. Accidentally, this has turned into a bit of a Corsair extravaganza, ladies and gentlemen. I don't even know where I'm going. Carnage. This video is chaos already, and we're only 5 minutes in. No. Oh my god, no. The first thing to do with the motherboard is the CPU. Now this is pretty easy to do. Pull the arm up, open the socket and drop the CPU into place. Make sure your golden triangle on this motherboard is down in the bottom left corner. That's basically the way it goes for all Z790 motherboards, and the socket cover will just pop its way off, never to be seen again. In all seriousness, do try and keep hold of this, as if you need to like RMA your motherboard or you want to sell it one day, really useful to have on hand. RAM is next up then, so I've got 4 DIMMs in this build. These are obviously going to populate all the slots, and I'll be adding them in from the CPU outwards. So 1 DIMM just here, line it up, apply a bit of pressure, 2 DIMMs, 3 DIMMs, and of course the 4th and final DIMM. All of these are going to be beautifully controlled in Corsair iCUE a little bit later. Next up is the M.2 SSD installation, for which you'll want one of these, a teeny tiny screwdriver. Take a look at the top slot just here, unscrew the screws on the left and the right hand side, as opposed to just the left or the right hand side, and that is going to reveal the very top NVMe slot. Add the Samsung 990 Pro into here using this little toolless latch to leverage it and hold it into place before putting the heatsink back on and completing the package. While the bulk of the motherboard assembly has technically been done, I am going to do a bit of prep for the cooler. You should find one bag that says Intel HW, Intel hardware on it. That's what I'll be using and will need for this build. The first of those pieces is one of these 3 bags. Now you can see here, one's for 1150, one's for 2011, and one's for 1700. 1700 is the one we need. And then you'll also find a backplate that looks a little something like this. That's what's going to brace the cooler to the motherboard. So take your backplate and take these screws for now. The rest we're going to save for later and deal with in about 10 minutes time. Grab the motherboard, and then on the back you'll find 4 holes. Now on some boards you might see the holes have got sort of various iterations. It doesn't really matter which ones we use. I'm going to go for the outer ones and just adjust the back plate to the holes as we go. Get the whole thing all lined up, and once it's been lined up, lay the motherboard flat on top of the back plate. All we then need to do is add each of these posts into the back plate holes now poking through the motherboard. As I say, in reality it doesn't matter which bit of the hole you poke through, just get it through, tighten the screw, and we'll deal with the rest later. Once this is all said and done, it's time to move the motherboard into the case. I'm going to lie the case down flat, as I think generally it's a better way of doing things. Slide the board in. All the standoffs here will be in the right place, with it being a full-size ATX case and a full-size ATX motherboard. You'll then be able to just about see we've got 3 screws at the top, 3 along the middle, and 3 down the bottom that need to be installed. These go into the pre-installed standoffs, and the screws you need come included with the case. So 3 at the top, 3 across the middle, 3 along the bottom. Try not to miss any out. Cool. So the cooler is next up, and the cooler's going to go at the top of the chassis, in this gap just here. First things first, I'm going to pop the fans onto the radiator. So debag it. Debag the fans, of which there are 3. So 1, 2, and indeed the 3rd one here. These are pretty nice. Not seen a design like this before, and the grey accents match perfectly with the rest of the build. Of course, I do include a bag of screws. These are these long radiator screws just here, and I'll be using these to fasten everything in place. They also include washers, which are well worth using. I'm going to pop off the top panel before putting the radiator in. A bit of muscles needed, but thankfully, I am here. He says as he struggles to get it off. There we are. One of the hardest things when installing the RAD is always threading all your cables through, because if you don't thread the cables through now, you best believe cable managing it later is going to be a bit too tricky. Then the radiator is going to clip in, pull all your slack through now, make your life nice and easy, and then you've kind of got to use one hand to hold the RAD in, while then grabbing with your screwdriver, a screw to actually hold, to actually hold the whole thing into place. Let's try that again, shall we? There we go. Now your first screw's important, but don't be relying on that one to hold the whole thing in. Make sure you get at least 2 screws in first. So there we go. And before you know it, you'll have a much more secure radiator that isn't likely to go anywhere. So we can do this one just here as well. Nicely done. And a third and a 5th and 6th screw on the right hand side. So 1 screw at a time, and once these are all in, the RAD is good to go. Water block goes on next with the Corsair faceplate looking nice and pretty. Run all those cables through your management holes once again and tighten the cooler up using these 4 included thumb screws. Thermal paste is happily pre-applied. Final thing, just to add the dust filter back on. There we go, make sure the dust stays away. Then pop on the top plate. Nice. With this though, I think we're making really good progress. I was going to install the GPU next, but I'm going to instead do a couple of other bits first. First, add the RGB fan into the back, and then try and get our nice little mini nano leaf panel set up as well, get those all working. And now that I think of it, I'm not actually sure I want to use the screen module. I kind of like how this new water plate looks.
I knew it.
The editor Dan called this. So I will leave this linked in the description if you still want to go and check it out on the Corsair web store. But I think the RGB that's as standard and doesn't cost us any more money will look just as good, if not for this particular build, maybe even slightly better.
The last time you made something with those triangles.
It didn't go well. Well, I'm hoping that today I'm not going to drop the triangles. I've made my shape. These are a bit fiddly. Let me try and put them in the case and build out from there. Maybe that's where I'm going wrong. Definitely going to take some fine tuning, but I think for now, we're all good. And obviously when it's powered up later, it should look pretty sick. Graphics card could be next, but I think instead I'm going to add in the power supply and the RM shift. First things first, get all the cables that we want to use plugged up and screw the power supply in, and I'll rejoin you to see how the whole thing really, in this particular case, is actually gonna work. This is such a weird feeling. It just doesn't feel right, but obviously, I mean, it is right. It's by design. So I'll screw this in and I'll rejoin you in a minute. How exciting. Ignore the total lack of cable management so far, but you can kind of see how this works. I mean, I don't know why they've put the graphics card one nearest to the end of the power supply. That would make sense to me this side, due to the fact the CPU's got to run up the top left. But as far as cable management goes, I kind of get it. I have actually also picked up some custom cable extensions for this build. Can't use them for the GPU power as they're a little bit few and far between so far, but for the CPU and the motherboard, I'm going to add those in. Gives it a bit of an aesthetic touch and makes the whole thing a lot nicer. And now it is finally time for the graphics card. RTX 40 series, what a controversial beast. I like 40 series performance-wise, still like it price-wise, not so much. But this build is hardly a cheap system, so I can't exactly say that this is the only reason the build in its entirety is expensive. Now what I do need to do is go ahead and remove a few of the PCI lane covers. So for me today, it's the 2nd, 3rd, and 4th. Here we go. This is an exciting moment. The GPU though, you forget how heavy these 40 series cards really are. There we are. Lovely stuff. Clicker in. He says, doesn't want to click in. Actually does not want to click. Yes, it did it. It was a tiny little click. I'll see if we can get a sound replay for you. But trust me, it is in. Now you'll see there's not much, but there's a bit of a wobble here. That's going to be fixed once those thumb screws go back in, and the PCI Gen 5 power cable will tidy things up nicely to get the whole thing fully secured and of course powered up. And with that, I think the build today, ladies and gents, is just about finished. But we are not at the end of the video, by no means. We need to see what this thing looks like when it's all powered up, RGB, warts and all, and then take a look at performance to make sure all the right metrics sit in the right places. So hold tight, I'll see you in a second, but first, it's time for a freaking sick GeekaWhat montage. Oh yeah, do the boogie. Boogie. Taking a look at performance then, and it makes sense to kick things off by looking at Warzone 2, one of the biggest multiplayer titles out right now. At 4K high settings with DLSS 2.0 enabled and set to the quality preset, This build pulled in an impressive 111 frames per second. Of course, if you're after that more competitive 140 or 150 FPS on average, you can tune things down to 1440p for even higher frame rates. It was a similar story actually in Modern Warfare 2 Remastered. 4K high DLSS quality, so the same settings as before, and the build yielded 117 FPS on average, so 6 frames per second or so more. Once again, some strong performance numbers here, as you'd expect, as these two games mechanically are actually very similar. Fortnite was also on the list of games to test today. 1080p competitive settings pulled in over 300 frames per second. You guys tell me that you love to play at 1080p with the render distance set to far and everything tuned down to low, so that's what we tested. Apex also performed well. 4K high in this title delivered 155 FPS, enough to satisfy even the highest end 4K gaming monitors, while Overwatch 2 at 4K Ultra also delivered strong results of 187 FPS on average to be precise. Visibly, the gameplay looked fantastic, and Overwatch 2 brings that slightly better on-screen edge over, of course, that last gen and slightly older Overwatch original title. Next up is Battlefield 2042. I tested again here at 4K high with DLSS enabled and set to the performance mode, delivering 114 frames per second, while F1 2022 was also on our roster. 4K ultra high preset here, and this build pulled in a very solid 189 FPS on average. This really is a build that means business for gaming at 4K high settings across the board in the latest titles. You can find links to all the parts mentioned today down below for a range of regions. Thanks for tuning in, and as always, we'll see you in the next one.